In this video, I will discuss cloud computing models and services common in enterprise environments. This video will cover CCNA Objective 1.4, describe the effects of cloud resources on enterprise network architecture. And in this video, I'm going to talk about the different cloud models used in enterprise networks, as well as what services are available through the cloud. Cloud computing is the delivery of on-demand computing resources over the internet. These resources can be applications, services, development tools, network equipment, and even IT support. All of these can be provided via the cloud. Cloud providers use a pay-for-use or pay-as-you-go model similar to that of a utility so that an organization only pays for the resources that it uses. In very simple terms, you can think of cloud computing as leasing computing resources from a provider that are accessed over the internet. Now, there are many benefits of cloud computing, from reducing capital expenses to improving reliability. So pause for a few minutes and spend some time looking over this table and the different benefits and their definitions of cloud computing. Next, let's talk about the different cloud models. There's two main models, and then there's a hybrid. So we have public clouds and private clouds, and then we have a combination of the two, which is known as hybrid cloud. So let's take a deeper dive into each. Starting with the public cloud, this is a model where a cloud provider offers and sells cloud services to other companies and to individuals. These services may be free or could be offered on a pay-per-use model, such as paying for online storage. The public cloud uses the internet to provide services. So in the diagram shown on the slide, we've got a user who authenticates, uses the internet to access some third-party provider's data center where she can access resources. And these typically could be accessed through a web browser. Now, there are also private clouds. Private cloud-based applications and services are intended for a specific organization or entity. A private cloud can be set up using the organization's private network, though this can sometimes be expensive to build and maintain. Also, a private cloud could be hosted and managed by an outside organization and accessed over the internet. And then finally, there are hybrid clouds, which combine the aspects of public and private clouds and bound together by technology that allows data and applications to be shared between the two clouds. By allowing data and applications to move between the private and public clouds, the hybrid cloud gives companies greater flexibility and more deployment options. So how does a user actually connect to a public cloud? There are three methods in which this can be done. It can be done over the internet, but through a virtual private network or VPN, but also over a private WAN. When connecting to public clouds, each of these methods that we talked about, internet VPN, and private WAN, have some strengths and weaknesses, as you can see in the table. Internet connections to the cloud are convenient and make migration to other providers easy. However, the internet's not secure and doesn't offer any service level agreements or quality of service guarantees. Internet VPNs still traverse the internet, still can't provide QoS or service level agreement guarantees, but they do have the benefit of being secure and allowing for easy migration to a new provider. Private WANs can provide security, quality of service, and come with service level agreements, but it makes it more difficult to switch to other providers. So what can be accessed from the cloud? The National Institute of Standards and Technology, or NIST, defines three main cloud computing services. There's software as a service, platform as a service, and infrastructure as a service. Software as a service, or cloud-based applications, run on distant computers located in the cloud that are owned and operated by the cloud provider and that connect to users' computers via the internet, and typically over the internet via a web browser. The provider is responsible for licenses, installation, and support of the applications. The applications run in the provider's data center on virtual machines that are hosted on servers. Now, there are some common software as a service applications, and these include Apple iCloud, Google Drive, and Dropbox, all of which you might be familiar with. Also, Office 365 is an example of software as a service productivity software, as is Gmail and Hotmail. Then there's platform as a service. With Platform as a Service, providers use cloud-based integrated development environments with everything a developer requires to build and deliver web-based applications. It's a complete development and deployment environment located in the cloud. Platform as a Service allows the customer to avoid the expense and complexity of buying and managing software licenses, the underlying application infrastructure, the middleware, and development tools and other resources needed to develop applications. All this is hosted in the cloud by the provider. The cost and complexity of buying and managing all of these resources is then the responsibility of the cloud provider. So examples of Platform as a Service, that includes development, database management, business analytics tools such as Windows Azure, Heroku, and Force.com. Finally, there's Infrastructure as a Service. Infrastructure as a Service is an instant computing infrastructure provisioned and managed over the internet. The customer pays only for the infrastructure they use. With Infrastructure as a Service, the customer avoids the expense and complexity of buying and managing their own physical servers and other data center infrastructure. The provider manages the infrastructure while the customer purchases, installs, configures, and manages their own software and operating systems, and of course the applications that they're going to run on the infrastructure. Examples of Infrastructure as a Service include website hosting, high-performance computing, big data analytics, and Amazon Web Services or AWS.